Good morning, students. We were discussing squares and square roots and we completed this problem. So all of you try the next one. Find the square root of 7,921 in long division method. Rishikesh, you want to answer?
Yes, sir.
Okay, what is the first step in doing long division method?
Sir, we have to group two digits.
From which direction, right or left?
Sir, left to right.
From right to left.
Okay, sir.
First these two, then these two. Okay, 79.
Sir,
Yes,
sir, 8 are
8 into 8, 64.
6.
Okay, subtract.
Sir, 15.
15 and take down 21. So you're getting 21 here. So whatever number you got here, that what we have to do?
Double
8 twos are 16.
16.
This blank and this blank we should fill by the same digit.
Yes, sir.
This digit will work here.
160. Papa, 960.
Yes, Rishikesh, which digit you have to use?
Sir, I am doing with 11.
You cannot use 11 in the place. You have to use a single digit in place of that blank.
Okay, sir. Number 54 plus 8.
Okay, Rishikesh, you try with 9.
Yes,
169.
sir.
169 into 9. What are you getting?
Sir, 1521.
Okay, you're getting the same number 1521. So subtract that and get the remainder. Therefore, what is the square root of 7,921?
89.
89 is the correct answer. Very good, Rishikesh. But you're taking much time to solve that. See, when you struck like that, what you can see is if because it is a perfect square root, you just take a look at the last digit. You just take a look at the last digit, that is 1. So 9 nines are 81. It's having the unit digit 1. That's why you can take 9 directly. Okay.
Okay, sir.
So you can mute yourself, Rishikesh. This is the answer. And we go on to the next question now. So all of you try the next question. Find the square root of these two mixed fractions. Who will try the answer? Then you can try the first question.
Sir, first
You can
question.
try the first question.
Yes, sir. Sir, first we want to convert into improper.
square root of 6 9 by 36. So 9 by 36, can we cancel the fraction? Simplest form,
Yes, sir.
9 ones, 9
Sir,
fours.
fourths.
Can we write square root of 6 1 by 4?
Yes, sir. Sir, improper now.
6 1 by 4, now we can convert into improper.
Sir, 25 by 4.
25 by 4. Now root a by b, can we distribute the root to both numerator and denominator?
Yes, sir.
So that is root 25 divided by root 4. So that you are getting, what is root 25?
Sir, 5.
What is root 4?
Sir, 2.
2. So this is the final answer, 5 1 by 2. But if you want to express the answer in mixed form also, you can do that. 5 by 2 mixed form.
5.
5 by 2 mixed form, mixed fractional form.
Sir, 2 of 1 by 2.
Yes, Harshvardhan, you got the correct answer. Abhiday, will you try the question in this? Abhiday, will you try the second question in this?
Yes, sir.
Yes. Square root of 5 41 by 16. Okay, 41 by 16 is still improper fraction, right?
Yes, sir.
41 by 16 can be again converted into mixed fraction.
Yes, sir.
So we convert 41 by 16 into mixed fraction.
Sir, 9 by 16.
16 twos are 32, right?
Yes, sir.
And remainder
So 9.
2 9 by 16. So this is nothing but 7 9 by 16, isn't it?
Yes, sir.
Okay, now you can convert this into improper fraction.
Sir, 1 minute. Sir, 120.
Yes, you got numerator 121 and denominator is 16. Now, what's the next step?
Sir, you can check the root to 2 times.
Yes, you can distribute the square root to numerator and denominator. Root 121 divided by root 16. What is root 121?
So 11.
11. Denominator.
4.
Okay, if you want to write it in mixed fractional form, what is the answer?
Sir, 2, 3 by 4.
2 3 by 4. Very good, Abhiday. You can mute yourself.
Okay, sir.
In the textual solution, they converted into even decimals also. You can also convert into decimals. So these are the questions we discussed in this chapter: square, square root, cube, cube root. And next topic we are going to start is algebra. Give me a second. I'll copy the questions and come back. Yes, students, next chapter we are going to start algebra. An algebraic expression is a mathematical phrase that has various components like numbers, letters, and some symbols. So, in this chapter, we will learn what these components are called in an expression and how they are used. So, mainly we are going to focus on algebraic expression. What are algebraic expressions? Sorry. So, we are going to concentrate on algebraic expression. What is algebraic expression? So, in this chapter, we shall look at various algebraic concepts and their definitions also, such as constant, variable, terms. What do you mean by term? Like terms, unlike terms, algebraic expression, application of fundamental operations, addition, subtraction, multiplication, and division. And we also learn how to solve equations also. So, to build an algebraic expression, we want some building blocks, and they are first let us discuss about constant. What is constant? A number having a fixed numerical value is called a constant. For example, you take numbers like 2, minus 1, 3 by 2, minus 4 by 5, etc. So they didn't change their value. Always their value is same. Such type of numbers are called constants. And now we discuss about variable. What is variable? A number which can take various numerical values is known as variable. And generally we use small English letters in algebra to represent variables, like we may use small a, b, c, x, y, z, etc. You can use any letter. They are also called literals. So these are variables. A number which is a power of another variable is also a variable. For example, you take x square. This is also called a variable. You take y to the power 4. This is also a variable. But the power should not be 0. Why? Because, for example, if the power is 0, any number to the power 0 will become 1 and it is going to be a constant. So other than 0, it may have any power. So it is called a variable. But this is a constant. Only power 0 will become a constant. Why? Because any number to the power 0 will become 1. Except 0, any power it may have, these are called variables only. A number which is the product of constant and a variable is also called a variable. For example, if I take 4x square, this is the product of 4 and x square. 4 is a constant and x square is a variable. The product of a constant and variable is also a variable. You remember only one thing, variable means it is having a variable part in it and which is not having any particular value. It may change. So even if you apply fundamental operations between these variable terms, then it is going to be still a variable only. Now we can define what is algebraic expression after knowing constants and variable. So now let us learn what is algebraic expression. Algebraic expression, we can define it like a combination of constants and variables a combination of constants and variables connected by all the fundamental operations like plus, minus, into, and division. Signs is called an algebraic expression. What are the examples for algebraic expression that we can take? For example, I can take 2x plus 3y. Yes, this is an algebraic expression because it is a combination of constants and variables connected by all the fundamental operation rules. 4x square plus x plus 2 is also an algebraic expression. X by 3 minus 1, this is also an algebraic expression, etc. It may have more than one variable also. As you can see from the example 1, x and y both are variables. So more than one variable also you can take. Now we can discuss parts of an algebraic expression. So the one is terms. What do you mean by terms of an algebraic expression? Terms. What do you mean by terms? Parts of algebraic expression separated by either plus or minus. They are parts of an algebraic expression separated by either plus or minus. So remember one thing, only plus and minus, they are going to separate the terms. Into and division, they are not going to separate the terms. Let's take the example, same example I'm taking, 2x plus 3y. Here, plus is dividing this algebraic expression into two terms. That means 2x is the first term, 3y is the second term. Similarly, you take 4x square plus x plus 2. Here 4x square is the first term, x is the second term and 2 is the third term. Similarly, x by 3 minus 1. See here, division also there, but division is not dividing the terms like x is first term, 3 is second term. That is wrong. Division is not dividing the terms. Only plus and minus will divide the terms. That means this entire x by 3 is the first term and this one is the second term. So students, still here we discussed constant, variable, algebraic expression and terms. So any particular doubts in these topics? We discussed four topics. So you have any doubt, you can ask. Manaswini, you have any doubt, ma? Manaswini,
Sir,
you have any doubt?
sir, I didn't understand algebra method.
Algebraic expression means it is a combination of constants and variables. You understood constant and variable, right?
No, sir.
Constant means whose value is fixed. For example, we take 3, 4, -1, etc. Do they change their value or they have the same value?
They have same value.
They have a particular value which they don't change. Such type of numbers are called constants. And variables are not like that. We take a letter to represent that. It may take any value. For example, A, B, C, etc. They are called variables. So algebraic expression means it is a combination of constants and also variables connected by the fundamental operations like plus, minus, into, and division. Okay. For example, you take 2x plus 3y. Here 2 is a constant, x is a variable, 3 is a constant, y is a variable, and they are connected by plus. So 2x plus 3y is called an algebraic expression. Similarly,
Sir,
yes,
what do you mean by terms?
terms means whenever plus and minus comes in algebraic expression, they are going to separate the terms. Okay, I will write separately here. I took some examples now. So this is the algebraic expression like 2x plus 3y. I want the first term. I want the first term and I want the second term. Okay, what is the first term of this algebraic expression, Balaswini?
Sir, 2x.
Yes, it is 2x because plus is going to divide the terms separately, separated by plus. And what is the second term in this? 3y, right?
Yes, sir.
Suppose I have minus x plus 4z. This is also an algebraic expression. What is the first term?
Sir, minus x.
Minus x. And what is the second term?
Sir, 4z.
4z. Some algebraic expression may have third term also. If it is there, we will write, otherwise we leave it blank. Let's take x minus 4y square plus 5z. Okay, this is the algebraic expression. What is the first term, Manaswini?
Sir, x.
Second term?
4y square.
No, along with the sign you should write. Second term is minus 4y square. Before 4y square, you have minus, right? So every
Yes.
time, wherever you take, you have to take the sign before it, right?
Yes, sir.
Third term is
Sir, 52.
5z. That
Yes,
is
sir.
z, variable z. Okay. So this is how we separate the terms. That means terms are separated in an algebraic expression by which symbols?
Sir, plus minus
Yes,
division minus.
only plus and minus. See, for example, if I write x into y, okay, how many terms are there in it?
Sir, 2 terms.
First term is x, second term is y, right?
Yes, sir.
That is wrong because into is not going to divide the terms. Okay, this is treated as a single term. X into y in algebra is treated as a single term xy. You understand?
Okay, sir.
Why? Because into and division they won't separate the terms. Only plus and minus are going to separate the terms. Is it clear?
Yes, sir.
Okay. Now we will continue after terms. So any other students you have doubts, you may ask. Abhyuday, any doubt? Abhyuday? Abhyuday, I'm not audible. Harshvardhan,
Sir,
you have any doubt?
sir, why division cannot divide the terms?
Come again.
Sir, why into and division cannot divide the algebra expression into two
It is
terms?
by the definition we are taking terms means whichever are separated by plus and minus, they are separated as terms. We
Why
don't
the
use.
sir?
Why?
Why
Because
single
whenever you multiply, you will get the product. Suppose x into y you do. X into y we write as a single product xy, right? It is treated as a single term.
Sir, why single term?
Because it is a product, it is not sum and difference. Products and quotients are treated as single terms in algebra.
So in sum and minus sum and difference means
Sum, we take sum of two numbers, that means two separate terms. Difference of two separate terms, like that. But product of any numbers of, like even if you take two or more, completely you're going to do the multiplication and you're going to get the final product, no? That is treated as a single term. Mayuk, you have any doubt? Mayuk, speak loudly.
Sir, I have a doubt in Variables.
Okay, what is, you don't understand what is variable? It is a
Yeah, we
value
don't.
which may change, okay, based on the situation. For example, you have 2. 2 means always 2 only. It is not representing any other value. But if you take x, it may represent any value depending on the situation. That's why it is called variable.
No, you
Okay.
told 4 into x square equal to variable. Why?
Because 4 is a constant and x square is a constant. The product will also become a constant, right? I'm sorry. Product will also become a variable, right?
Yeah, why?
Why? Because we don't know the value of x square. Then 4x square value also we don't know, right?
Okay.
That's right. So we are going to continue after terms. Now we are going to discuss what is coefficient of a term. What is coefficient? Coefficient of a term. So what do you mean by coefficient? Let's consider any term, like suppose I am considering 5x square. What is the coefficient of this variable part x square? It is called 5. So in this 5x square we call 5 is the coefficient. 5 is the coefficient of x square. So whatever multiplier is there for the variable part, that is called the coefficient. And we can also call x square is the coefficient of 5. And also we can do one more thing, that is 5x square can be written as 5x into x. So we can write 5x is the coefficient. 5x is the coefficient of x. That means coefficient means you can just remember one thing. You try to express the given term as a product of one or more terms. One factor is called the coefficient of another factor. We can also call x is the coefficient of 5x. Here in all the coefficients, this 5 is called numerical coefficient of x square. Why it is called numerical coefficient? Because it is a number or it is a constant, but remaining all coefficients are having variable. So 5 is called the numerical coefficient of x square. And it's also called the literal coefficient of x square. Numerical coefficient or literal coefficient. Next we are going to discuss like terms and unlike terms. Like terms. What do you mean by like terms? Two or more terms having same variable part are called like terms. Same literal coefficients are called like terms. For example, I have 5x and 3x. What is the literal coefficient in this? X. What is the literal coefficient in this? X. If the literal coefficients are same, then we call them are like terms. So we can call 5x and 3x are like terms. Let's take 5x and something like 3y. Here the literal coefficient is x and here the literal coefficient is y. So as they are different, then we write them as unlike terms. They are unlike terms. So what do you mean by unlike terms? Terms having different literal coefficients are called unlike terms. So 5x and 3y are unlike terms. So simple, like terms means having same variable part or literal coefficient. Unlike terms means having different variable part or literal coefficient. We'll take some more examples for like terms. Or I can take 2xy and minus 3xy. They are also like terms. One more example for unlike terms, we can take 7x square and minus 4x square. They are having same variable part. And for creating unlike terms, I'm adding y here. So that x square and x square y are different and they are not unlike terms. We'll take like terms one more example. 2x square and 3x square like terms. And here we can take 3x cube y and 4xy. So here the variable parts are different. They are called unlike terms. Now we are going to discuss what is polynomial. Polynomial. So before we discuss polynomial, any doubts you can ask? Mayuk, any doubt? Yes, Mayuk. Like terms and unlike terms. Mayuk, speak loudly.
Sir, I cannot understand like terms and unlike terms.
Like terms are having same variable part. For example, you take 5x and 3x. What is the variable part in 5x?
Sir, 5.
Variable part is x. 5 is constant, no?
Okay.
In 3x, what is the variable part?
Sir, X.
Because they are same, we can call them like terms. Okay?
Okay.
And 5x and 3y, what is the variable part in 5x? X, right?
Okay.
Speak loudly, Mayuk. In 3y, what is
X,
the
sir.
variable part?
Sir, Y.
So because they are different, they are unlike terms. That's it. Okay?
Okay.
Okay, now we'll continue with polynomial definition. What is polynomial? It is an algebraic expression in which the variables involved have only non-negative integral powers. So I will write the condition. It is an algebraic expression. It is an algebraic expression where variables have only non-negative integer powers. Okay, what do you mean by this? We know non-negative integers. What are non-negative integers? Other than negative integers, remaining all are called non-negative integers. So 0, 1, 2, 3, 4, etc. But negative integers are not accepted in this. Okay. Let's take for example 3y plus 4x square minus 5. Okay, is this a polynomial or not? So what is the condition? First of all, it should be an algebraic expression. Yes, this is an algebraic expression. What is algebraic expression? It is a combination of constants and variables by the application of fundamental operations like multiplication, division, addition, subtraction. Yes, this is an algebraic expression. Then what is another condition? It should have variables having only non-negative integer powers. Here there is no power of y. What is understood? If there is no power of y, 1 is understood. So here 1 is there, here 2 is there, and here there is no variable at all. So if there is no variable at all, you can create any variable and you can think 0. Why? Because any number to the power 0 will become 1 and 5 into 1 is again 5. So here the power is 0. So you can see this 1 is non-negative integer, 2 is non-negative integer, and 0 is also non-negative integer. Because in this algebraic expression, all the variables are having non-negative integers, then I can call this is a polynomial. Example of polynomial. So this is a polynomial. We'll take one more example. 2x cube minus 3x square y plus 4xy minus y square plus 17. So whether this is an algebraic expression or not, we need to check. So what is the condition? Every variable should have a non-negative integer power. So here variable is having power 3, variable is having power 2. There is no variable power for y, we can call it 1. So 1. here 1 1, here 2, here there is no variable power. So even if you want to involve the variable, you can write any variable and write the power 0. So you can observe all the powers: 3 2 1 1 1 2 0. They are all non-negative integers. So because the powers are non-negative integers, this is a polynomial.
Sir,
Yes, Mayuk,
sir, any another expression there like polynomial?
come again.
Sir, any algebraic expression like polynomial in another?
Yeah, algebraic expression can be polynomial and it cannot be a polynomial. For example, you take the examples for algebraic expressions which are not polynomials. For example, if I take, so these are polynomials. These are polynomials. For example, if I take x plus 1 by x, what do you think, Mayuk, is this a polynomial?
Sir, no.
Why? Because we can write it as x is x power 1, but 1 by x is nothing but x to the power minus 1. Here, I told you that to become a polynomial, negative powers are not accepted. So because of this, it is not a polynomial. Simply, you can remember one thing: the variable parts should not be in the denominator. For example, I take 1 divided by 2x plus 5. This is also not a polynomial. Why? Because the effective power of this x will become minus 1, because in the numerator, in the denominator is 1. So new in the denominator is 1, in the numerator is going to be minus 1. That's why it is not a polynomial. So this is also not a polynomial. So polynomial means very simple: we have to check the power of every variable. If it is a non-negative integer, it is a polynomial, otherwise it is not a polynomial. And fractional powers also not accepted. For example, you take something like 3x square plus y to the power 2 by 3 plus 3. So this is also not a polynomial. Why? Because this variable is having power 2. This variable is having power 2 by 3. So is 2 by 3 a non-negative integer? No, actually it is not integer only. That's why this is also not a polynomial. This is also not a polynomial. So fractional powers are not accepted and negative powers are not accepted. Only non-negative integers are accepted. Yes. Mayuk, you can mute yourself. Okay. Next, a polynomial in one variable and a polynomial in two variables. What is this? Polynomial in one variable. Polynomial in one variable. What do you mean by this? It should be a polynomial written using only one variable. For example, 2x square plus x minus 2. This is a polynomial in one variable, that is x. There are no other variables are used. X minus 4, polynomial in one variable. 5x, polynomial in one variable. 3x cube minus 2x square plus 1. This is also a polynomial in one variable. What is that variable? X. You may write using another variables also, like 5x, 5y square minus 4y, 2y, etc. But it should have only one variable. And next, polynomials in two variables means polynomial in two variables. That means we are going to use two variables to create the polynomial. For example, 2x minus 3y. There are two variables are used, x and y. So this is a polynomial in two variables. 3x square plus 2xy minus 4y square. This is also a polynomial in two variables. AB plus a square minus b. This is also a polynomial in two variables. First of all, it is a polynomial because all the powers are non-negative integers. Then they are having two variables. That's why they are polynomials in two variables. Now we are going to discuss one important topic called degree of a polynomial. degree of a polynomial. So what is degree of a polynomial? The highest exponent of the variable in a polynomial of one variable is called the degree of the polynomial. Not only one variable, you can take more than one variable also. The highest exponent of the variable, the highest exponent of the variable in a polynomial of one variable. We can take more than one variable also. That I'll take example later. First, we'll take one variable polynomial. A polynomial in one variable. How to check the degree? The highest exponent of the variable is called its degree. For example, I have minus 2x cube plus 3x square minus 7. I have this polynomial. I want to find its degree. So the variable has having the power 3. This variable is having the power 2, which is the highest exponent here, 3. So we can call this polynomial is having degree how much? Having degree 3. So degree 3 polynomial is called cubic polynomial. Degree 3 polynomial is called cubic polynomial. So I may have 4x square minus 2x plus 1. Highest exponent of the variable is 2. So this is having degree, or the degree of this polynomial is 2. Is having degree 2. So degree 2, we call it quadratic polynomial. Quadratic polynomial.
Sir,
For example, we have degree 1. Yes, Mayuk?
sir means we have degree for what is it called?
Come again. Degree 4. Degree 4 is biquadratic.
Means
Biquadratic. It's the name of the polynomial is biquadratic. Degree 4. So minus 5x plus 3. What is the power of this variable x? If there is no power, we understand 1. So that is this polynomial is having degree 1. Degree 1. So degree 1 polynomial, it is called linear polynomial. Linear polynomial. Sometimes the degree is also a variable, something like ax to the power n plus bx to the power n minus 1 plus cx to the power n minus 2 and so on. Okay, up to something like we wrote a variable like f, a constant like f. Now in this is having degree n. So we write it as polynomial of degree n. Polynomial of degree n. So this is the meaning. So this is the meaning of degree of the polynomial. What is degree of the polynomial? The highest exponent of the variable in the polynomial is called degree of the polynomial. So we took different degrees of polynomial. Now we are going to divide the polynomials with respect to the number of terms it is having. Now classification of polynomial based on number of terms it is having. Okay. If a polynomial is having only one term, what do you call it? Monomial. If a polynomial is having two terms, then it is called binomial. And if it is having three terms, it is called trinomial. And more than three terms, we call it multinomial. Okay, monomial means having one term only. Binomial means having two terms. Trinomial means having three terms. And multinomial means having more than three terms. More than three terms. Okay, we'll take some examples. So first monomial, we take some examples. Example for monomial is, we take 5x. 5x is a polynomial and it is having only one term. 7a square is a polynomial and is having only one term. Minus 1 is also a polynomial and it is having one term. So there are examples of monomial. Binomial, having two terms. 2x minus 3, there are two terms, so it is a binomial. 4y square minus 4y, having two terms, binomial. 2xy plus 3x square, having two terms, so it is a binomial. Trinomial, having three terms. X plus y plus z, there are three terms in it, so it is a trinomial. 2x square minus x plus 9, it is a trinomial. 3x square y plus xy minus 2, it's trinomial. Multinomial, more than three terms. 3x square minus 2xy plus y square minus 2x square y. So there are four terms. That means more than three terms, it's called multinomial. So this is the classification based on number of terms. And one more important thing we're going to discuss, value of an expression. Value of an expression. What is value of expression? In mathematics, we come across many situations where we need to find out the value of an expression. The value of an expression purely depends upon the values of the variable that forms the expression. For example, I have a mathematical expression like 4x plus 7. If x is equal to 2, then what is the value of this 4x plus 7? In place of x, you substitute 2. That is 4 into 2 plus 7. 4 2s are 8. 8 plus 7 is 15. Then what do you mean? What do you call this? We can write like this. The value of the expression 4x plus 7 at x is equal to 2 is how much? 15. So this is called value of the expression. We take one more example like 3x square y plus 2y. Let's take if x is equal to 1 and y is equal to 2. What is the value? So let us simplify. In place of x, we are going to substitute 1. In place of y, we are going to substitute 2. Again, in place of y, we are going to substitute 2. So 1 square is 1. So 3 into 2 is 6. 2 2s are 4. So 6 plus 4 is equal to 10. So what we can write this, the value of 3x square y plus 2y at x is equal to 1 and y is equal to 2 is 10. So this is how we find the value of an expression. Okay, so these are the definitions we discussed today in algebra. Based on the definitions, let's solve the problems tomorrow. So by tomorrow, everybody must go through all the terms in algebra: term, constant, variable, polynomial, and classification of polynomials based on number of terms and what is the degree of the polynomial. So all the things you revise and come. So tomorrow we are going to discuss the problems based on algebra. Okay. So now we are going to start English. So English, I think adjective we are discussing yesterday, and we'll continue with that. Yes, adjective. We discussed all these types of adjectives, degrees of comparison, and yes, these questions I gave you yesterday for practice. Now let us try to answer them. Okay, who will answer the 13th question? Can raise a hand. Okay, Manaswini, can you read the 13th question?
Sir,
Yes.
Sir, uh, Anita is as taller
13th.
as
13th
sir.
question. 13th.
I cannot read the numbers. It has zoomed.
Wait a second. Wait a second.
He will
Yes, read the question.
he will have to count dash notes. His note.
These note, those note, each note, many notes.
These note.
These is used for plural, Manaswini.
Those sir.
Those also plural only. These means it is near us, those means it is far us, but both
Each
are
note.
plural. Each is used for singular, right?
Yes, sir.
So each is correct. These, you should know the difference between this and these. This is used for singular and these is used for plural. That's why note is singular, no? For singular, how can you use these? You cannot use. So you have to take care of singular and plural, okay?
Okay, sir.
Now what about 14th question?
Sir, Anita is as dash as her sister.
Yes,
Tall, taller, tallest, more taller.
more tall. Yes, which option is correct?
Anita is tall as her sister.
No, actually, when you are comparing between two things, you should use taller only. That
Tall.
is how we use Anita is taller than her sister. Directly we will use. But I told you yesterday one topic that whenever as used for comparison, you use the positive degree only. You cannot use as taller as. You should say as tall as. Yes.
Okay, sir.
So whenever as comes, which degree we have to use? Positive, comparative, or superlative?
Superlative.
Positive. That's why tall will be the correct answer. Manaswini, 13, 14, both you gave wrong answer. I want correct answer from you for 15th one.
Okay, sir. I was dash intelligent than my elder brother.
Yes, much, very, two, more.
I was uh, I was more intelligent than my elder brother.
Yes, more is correct. Why? Because it is a comparison between two persons. When comparison is happening between two persons, which degree we have to use?
Sir,
When comparison is happening between two things, which degree we have to use? Positive, comparative, or superlative?
so comparative.
Yes, that is more intelligent, most intelligent. Correct answer. Okay, Manaswini, you can mute yourself. And your other student, Varshita, can you answer 15th question?
Sir,
Yes. 15th one over, no? 16.
sir, 60.
Yes.
They were the dash of all the soldiers. They were the bravest of all the soldiers.
Okay, you gave correct answer, but how did you identify the correct answer? Can you explain?
Sir, because when soldiers
Yes.
is a plural.
Plural means more than two, we have to say, right?
Yes, sir.
One more clue also there to identify the bravest. What is the one more clue? See, we
Sir,
know.
when
Yes, yes.
were sir
Yes, yes, continue.
when were Means like present form is there.
It's not present form, it is past form verb. But what I'm saying is there is an article used the is used between the is used before superlative degree only. The is used before superlative degree only. Now what is superlative degree? Bravest. Brave,
Yes.
braver, bravest. And not only that, Lou, we have all the soldiers. All the soldiers means more than two only. When the
Yes, sir.
comparison is happening among more than two people, then we call it the superlative degree, that is bravest. Correct answer. What about 17th one?
Sir, we were too dash to lift the box.
Yes.
We were weak to lift. We were too weak to lift the box.
Yes. We are not able to lift the box. We are too weak. That means whenever, like as, you remember to also. As also you have to use positive degree. To also you have to use positive degree.
Was
Weak, weak, weaker, weakest. We have to choose weak. Varsta, can you ask you a question?
sir, yes.
Can you create a statement on your own which is having two? It should have two.
Okay. Sir,
Yes.
uh,
I
I
was.
weak to
I was.
I was heavy.
Okay.
Sir, I was heavy to lift
No.
to.
I'll give you one example. You try another example. I was too young to vote. What does it mean?
Sir, I was young to vote. Means I don't have that
Yeah.
ability to.
Yeah. You don't have the permission to vote, right? Minimum 18
Yes,
years you have to cross to get the voting, right?
yes, sir.
So I was too young to vote. That means we are not able to vote because of our age. Now, can you create one more statement based on two?
I was too small to lift. Uh, I was too small to.
Now you tell me, Varshita, one thing. The sentence whenever we are using to and to, it shows a negative sentence or positive sentence.
The positive sentence.
Negative sentence. It won't give you permission to take that. Okay, I was too young to vote. That means voting permission is given or not given.
Not given.
Okay, I'll tell you one more thing that the coffee, the coffee is too
Too bitter.
hot, too hot. Let's take too hot to take. Okay, that means it is a negative sentence or positive sentence.
The negative.
Negative sentence because we are not able to take the coffee because it is too hot, right?
Yes, sir.
Okay, now we can answer 18th question.
The house is bigger dash the school. The house is bigger than the school.
Yes, the house is bigger than the school. Whenever comparison is happening, we have to use than. Okay, very good,
Yes.
Varshita. You can mute yourself. Next student who is ready to answer next few questions. Samatvika, can you answer the 19th question? Samatvika,
Yes, sir.
19th question.
She is the most dash girl of, of her class.
Yes, read the options.
Rich, poor, clever, intelligent.
Yes, which one?
Sir, sir, intelligent.
Yes, correct answer. Why? Because most is not used as the superlative degree of rich. We say rich, richer, richest, poor, poorer, poorest, clever, cleverer, cleverest. But for intelligence, we use Intelligent, more intelligent, and most intelligent. So option D. What about 20?
Sir, I can answer.
Yeah, read the question.
The minister was more dash than the king.
Okay.
Uh, Popular.
Yes, popular is correct answer. Why? Because whenever more is there, more stronger we cannot use, more richer we cannot use, more wiser we cannot use. Why? Because if you want to use these words stronger, richer, and wiser, we don't use more. We directly say the minister was stronger than the king, the minister was richer than the king, the minister was wiser than the king. But here more is used. That means the popular adjective is having the degrees of comparison popular, more popular, most popular. Correct answer B. Next 21.
Little is for milk. Dash is for cows.
Yes.
Uh, Lot.
Lot is for cows. We say lot cows. Little means milk. We are saying only a little amount of milk. Cows, very less amount of cows are there. What is the word we use?
Sir,
Very little number of cows are there. What we are using the word. So for countable nouns, you have to use few. Okay. Cows are countable or uncountable.
sir, countable.
Countable nouns, we have to use few. Milk is countable or uncountable.
Sir, uncountable.
For uncountable, we have to use little. Okay.
Okay, sir.
Very good, Samathika. You can mute yourself. Next question. Harshvardhan, can you answer the next few questions?
Yes, sir.
Okay. You can go for 20 seconds now.
If Kapil is handsome, Kavita is
If Kapil is handsome, Kavita is dash.
beautiful.
Beautiful. Why? Because handsome is used for male gender or female gender.
Sir, male.
Male gender. And for female, we use beautiful, the word. Okay. It's beautiful. Correct answer. 23rd.
Smarter is followed by than, and dash is followed by two.
Harshvardhan is be a little bit louder.
Smarter is followed by than,
More,
dash
more,
is
more louder.
smarter is followed by than, dash is followed by two.
Okay.
So wiser.
No, wiser also we use than only. Smarter than, wiser than.
Yes. Weak. Happier is too happy. Sir, happier.
Happier also than only. He is happier than me. He is weaker than me. He is wiser than me. But whenever
Weaker.
suppose you are in fifth class, no, a fourth class student came, so you can say a statement. You are junior to me. It's not you are junior than me. You should say junior to me, right?
Sir, junior.
Yes, junior. Junior to me. You are junior to me. Junior is followed by to or than.
Junior two.
Yeah, that's why option B. What about, wait a minute. Let's go to Srivastav. Can you answer 24th question?
Sir,
Yes.
cold, colder
Read
is for
loudly. Read loudly.
colder is for cold. Dash is for famous.
Yes. Cold, the comparative degree is colder. Famous, the comparative degree.
Sir, your voice is stucking.
Srivastav, for famous, what is the comparative degree?
More famous.
Yes, more famous is correct answer. What about 25th question?
Wisest is for wise. Dash is for interesting.
Interesting.
Interest.
Yes, answer.
More interesting.
No. Wisest, they used comparative degree or superlative degree. Wise, wiser, wisest. They used superlative degree for wise, right?
Yes, sir.
So you should use superlative degree for interesting. What is the
Very,
superlative degree we use?
very interesting.
No, most interesting. Interesting, more interesting, most interesting. So option A, okay? So this is about adjective chapter and see also you can mute yourself. And next chapter we are going to start is adverb. And next chapter we are going to start adverb. Okay, what is adverb? The definition. An adverb is a word that modifies a verb. An adjective or an adverb itself is called an adverb. This is a very famous book. In this, famous is adjective and very famous. The very is modifying its meaning. So very is the adverb. He runs slowly. Runs is the verb and slowly is the word which is modifying the meaning of runs. So it is adverb. So what is adverb? It either modifies a verb, adjective or an adverb. Now types of adverbs we discuss. The first type of adverb, adverbs of time. Adverbs of time. Yeah, sorry for the past students. I was suffering from a little bit cold. So adverbs of time. They tell us when the action takes place. I went for a movie yesterday. So went is a verb and when did you go? When did you went? That is yesterday. So it's modifying the meaning of a verb. Vicky finishes all his tasks early. So how he finishes? That is, it is modifying the meaning of a verb early. So it there are adverbs of time, time related. Okay. Ago, after, early, yesterday, quickly, recently, today, tonight, tomorrow, etc. are all used as adverbs of time. Next type of adverbs, adverbs of manner. They tell us how or in what manner an action takes place. Sita speaks English. How she speaks English? Fluently. So fluently is modifying the meaning of speak, that is verb. The word which modifies the meaning of a verb is adverb. Read the instructions carefully. How you have to read? Carefully. So carefully is modifying the meaning of the word read. That's why it's an adverb. So peacefully, adverbs of manner means what? In which manner it's happening. It's saying the explanation. So peacefully, fluently, quickly, certainly, loudly, carefully, gladly, badly, fast, etc. Fastly actually. So etc. are used as adverbs of manner. Next, adverb of frequency. Frequency means how often, how many number of times it's happening. They tell us how often an action or event takes place. How often? How many times? Jita practices violin regularly. How often? Regularly. Nandu will come again. How will he come? He come again and again. Seldom. Often. Regularly. Never. Ever. Again. Frequently. Always. Usually. These are all called adverbs of frequency. Next type of adverb, that is adverb of place. They tell us where an action takes place. She took the lady. Yes, the sentence is completed, but to modify the meaning of the sentence, she took the lady. Where did she took? That is inside. She took the lady inside. So inside is the adverb of place. Arjun searched for water. Where did he search water? That is everywhere. So near, far, away, inside, everywhere, anywhere, here, etc. are used as adverbs of place, related to place. And next, adverb of quantity, extent, or degree. They tell us to which extent an adjective is modified. That is, your pen is too nice. The extent of the niceness of your pen is too nice. Purab is little tall. How much tall? Little tall. It is saying about the quantity. Quantity means size, and we also call it degree. Partly, fully, pretty, almost, very, more, much, any, none, too, little are used as adverbs of quantity, extent, or degree. So let's solve some questions. Let's answer some questions based on adverbs. So students, be ready. Fill in the blanks with the correct adverb from the options. Aryan, can you answer the first question? Read the question first.
Sir,
Read the question. The
sir,
first.
can you move the question to more right side?
Can you
Yes, sir.
see that? Yes.
Her brother did not bath dash as he had fever.
Yes.
Sir, yesterday.
Yes. Yesterday is correct because did not is indicating that it is happening in the past form. Okay.
Yes, sir.
So you can go for yesterday. That is C. And second one.
Dash my mother is preparing breakfast in the kitchen. Now,
Yes. How did you choose now?
sir, preparing is present tense.
Yeah, is preparing. That means is plus V1 plus inform is indicating present continuous tense. So it's
Yes,
happening now. That is
yes.
option D. Okay. What about third one?
Nobody will celebrate his birthday dash. Sir, tomorrow.
Tomorrow. So the reason may be suppose he got ill, he got admitted into an hospital. Anyone will celebrate his birthday? No.
No, sir.
So nobody will celebrate his birthday tomorrow. Very good. All you give correct answers. Next. Nishika, can you answer fourth question?
Ah,
Nishika,
sir.
read the fourth question.
Kavita dash goes to temple with her mother.
Yes. Which option is correct?
Sir, always.
Always. Yes. Always goes to temple with her mother. It is an adverb of frequency, always goes to temple with her mother.
Yes.
What about fifth question?
We have not submitted our forms dash. Sir, before
You said before. We have not submitted our forms before. No.
mm, sir, option A.
Option A, yet. That means till now we have not submitted our forms. That is yet. Can Ishka wait for one more question? I'll give you.
Okay, sir.
Yes, Nishika. Sixth question.
Rohit dash get up early.
Yes, answer.
Sir, always.
Yes, Rohit always gets up early. That is his habit. Okay, Nishika, you gave all correct answers. Harshvardhan, can you answer seventh question?
Yes, sir.
Remaining students, wait a minute, Harshvardhan. So here, so many students are not raising hand and involved in the class. Jashvi, Sanvi, Sharat, Jayvant, Bhuvana, Rishikesh, Surya, Srijana, Daksh, Shriyash, Varshita, Sahasra, Nishil, Neeraj and Vamshika are not at all active. Pranay, Vishwajit, Ritvik, Abhyuday. Only these students, regularly these students are involving in the class and answering. Sanvi, can you answer the next question? Sanvi, seventh question.
Sir,
Yeah, read the question, Sanvi.
we have dash gone to Agra. So never.
Yes, we have never gone to Agra. So remaining words are not matching there. Yes, eighth question.
His father has warned me dash. So never.
No, if you want to use never, it will come after has. Has never warned me. Adverb is placed at the end of the sentence. His father has warned me twice. Two times. Yes or no? Yes, Sanvi?
Yes, sir.
Means how many times? Two times. Ninth question.
He runs dash than your brother.
Yes, which comparison is
He, run,
yes.
he runs faster than your brother.
Okay, why did you choose faster?
So comparative degree.
Yes, why? Because here you have the clue than. So than comes, that means it is a comparative degree. Fast, faster, fastest. So you can choose option C.
Faster.
Yes. Okay, Sanvi, you can mute yourself. Nishil, can you answer the next question? Nishil, can you answer 10th question? Nishil, you are not audible. Bhuvana, not at all answering the questions. Bhuvana, can you raise your hand? Bhuvana, I told you many times to participate in discussions in class, but you're not doing it all. Why are you not answering questions, Bhuvana?
Sir.
Bhuvana, am I audible?
Yes, sir.
Okay, read 10th question loudly.
She could not reach reach on time because
Bona, you're not at all audible. You read loudly.
she could not reach on time because she was walking.
Bona, more loud.
She could not reach on time because she was walking very dash.
Yes. Walking can be related to which adverb?
Sir, slowly.
Yes, slowly is correct. What about 11th one?
They beat him dash.
Bona, read loudly, Bona.
They beat him dash.
Yes.
They beat him wantly.
They beat him?
Sir, option C.
Want no. They beat him badly. They beat him badly means more amount of suffering. Next, Bona, you answer one more question. Bona, you try this.
He was wandering dash in search of water.
Yes.
Sir, he was wandering everywhere.
Yes, he want water. He's feeling thirsty. He's wandering everywhere in search of water. Okay, Bona. Regularly, you have to raise your hand, involve in the discussions in class, ask doubts. You're not doing that. Next time, you involve in the class regularly. Shiradhya, you raised your hand and moved it back. Daksh, Sriyansh, Varshita, Sahasra. Nishil, can you answer the next question I am going to give now?
Yes, sir.
Nishil, am I audible to you?
Yes, sir.
Nishil, speak loudly.
Yes, sir.
Yes, Nishil, read 13th question.
We stayed at our home all the day and went dash.
We stayed at our home all the day and went dash. Yes.
Sir, sir, somewhere.
Not somewhere. We stayed at home only. That means you went nowhere, right?
Yes, sir. Anyway,
Nowhere. We
sir,
stayed at home only and we went nowhere. 14th one.
I saw him walking outside the room and called him. Called.
Called him out, called him in, called him up, called him above. You saw your friend walking outside the room and you called him
Yes, sir.
out, in, up, above. Where?
Sir, out.
Why out? He's already outside the room now.
Yes, sir. Sir, I think up, sir.
Why up? He's already outside the room and you called him where?
Sir, sir, above.
Where above?
Sir, no.
In. You called him in. You are inside the room and your friend is walking outside the room and you will call him in the room, into the room, right?
Yes, sir.
Read properly. Next question you have to answer correctly, Initial. Read loudly.
These books seem dash inspiring.
Yes.
These books seem more inspiring.
No.
Much inspiring, sir.
No.
Sir, this book seem
For inspiring, the correct form of adverb we have to use is
Lot, sir.
No, very, very, very inspiring.
Sir, what?
This book seems very inspiring to me like that. Okay, Nishil, you concentrate on adverbs chapter once again. Go through the chapter again and understand all the manner of adverbs. Okay,
Okay,
where
sir.
we are using them. Okay, students, it's 7:30. I stop the class here. You may leave the class now.